All right. Did everybody just get kicked off there? Because I had to reconnect as well. Okay, so yeah, nobody at Lawler's done, but everybody else is done. So we're going to move here. So what's the most critical part that Sal Khan talked about? What's the most critical part of the divisor for synthetic division to work? What's the most critical part of the divisor for synthetic division to work? Yes, exactly. It is long division in simple form, but what's the most important? Yeah, the coefficient of x has to be 1. Okay, and actually Sharon has a good point. It has to be x to the first power. Okay, it has to be x to the first power. I assume that I should say 2 critical parts. I'll mention that now for the recording. That's where my recording indicator is for me. Um, yeah, there's 2 critical parts. It needs to be x to the first power and it needs to have a coefficient of 1. A power of 1 and a coefficient of 1, or else it's not going to work because of what Sal Khan talked about, where you drop down. In that case, it was a 3, I think, on his problem. Dropping down that first coefficient won't work unless you have an x to the first power with a 1 coefficient. Okay, good, good. All right, what about this? What about this? Oh, right on schedule, right on schedule. What do you do if the divisor is 2x plus 3? What if you do if the divisor is 2x plus 3? Oh, do tell. Well, one, you could use long division. One, you could use long division, okay? But what if we want synthetic division to work? What if we want to do synthetic division? Okay, you guys both have it. Yes, you divide by 2, and you would put -3/2. Okay, well, you subtract 3 and then divide by 2. You'd put -3/2 in the top left box for the synthetic division. I would not do that. You're going to forget, especially if you're doing like a 5th degree polynomial or something like that. You might forget to do it. Yeah, I would just use a fraction because it's not too hard to use a fraction. I mean, especially something like, -3/2 or 1/2, something like that. That should probably work pretty well. Yeah, use -3/2 in the top left box for synthetic division. Yeah, but we're probably going to ask you guys, very, very, very important. If we ask you on a quiz or test to use long division, you have to use long division. Okay, even if you had like an x plus 5, and you could use synthetic division. If we ask you to use long division, you have to give us long division. Like you have to, follow the directions there because we want to make sure that you guys know that too. Because you could always use long division. And if you're doing like say a trinomial, like a quadratic, you have to use long division. Okay, so that division only works when x to the first power and a coefficient of 1. Okay. So finish up 10 and 11 at least. Raise your hand if you're done with 10 and 11. Okay, on 9 through 12 on that back page there. Raise your hand if you're at least done with 10 or 11. Okay. So we can go here. Let me switch up. So I'll pretty much just do the setup for 11 because I think you guys are in rhythm here. All right, first, what did you need here with the x to the 4th minus 7x squared? What did you need here in 11? All right, don't forget this part, guys. This is where the pre-AP students make mistakes. They just dive right into it. They dive right into it, and they don't see like the lay of the land, so to speak. What do you need here in the dividend? All right, what do you need here in the dividend? What's it missing? I didn't want you to start that. Number 1 and number 2, I was extremely tired yesterday. I'll fess up to it. I was extremely tired. I was more focused on the coefficient because where did I say it? Yeah, I like screamed at you guys. Cannot use when coefficient doesn't equal 1. I was so obsessed with that I wasn't thinking of fractions or anything like that. I was just seeing like the x and the r just not being fractions or coefficients. So yeah, sorry about that, but it does work. It gets a little hairy though, especially if you have to do stuff on like a non-calculator part. Okay, yeah, we're missing the x to the 3rd term. So Ria's right, we need a 0 x to the 3rd like placeholder. Okay, and we have x minus 2 equaling 0. So then we're going to have a positive 2. We're going to have a positive 2. And then we have 1x to the fourth, 0x to the third, negative 7x squared, positive 9x, and then negative 10 as our constant. All right, and then we can just set this up here. You drop the 1 down. All right, and then 1 times 2 is 2. Remember, you add together. 2 times 2 is 4. You add together, negative 3. All right, then you're going to have negative 6. You add those together, you're going to have positive 3. And 3 times 2, you have 6. And you'll have negative 4. We're out of numbers, so it looks like we have a remainder. Did I screw something up? Negative 6, 3. So 2, 3, 3. Yeah, no, this is fine. 6, negative 4, yeah, all right. Sorry, the answer key is wrong that they had here. So this is going to be x cubed plus 2x squared plus 3x plus, sorry, minus 3x plus 3 with a, we can do plus minus 4 over x minus 2. Okay, remember guys, it's not x plus 2, it's x minus 2. There's your remainder. All right, I will publish the answer key for this. If you want to see 9 and 10 here. We should have gone for number 9. All right, we're going to talk about this 0 remainder in just a second. Just take a look at number 12. Just take a look at number 12. Here's the right answer for 11. Okay, that's a negative 3x. That's a, you could put minus 4x over x minus 2 if you wanted to, but you're basically adding that remainder. Okay, forget number 11 here. Their answer was all screwed up. I had to write over it. All right, but there's the answer to number 12. Okay, and I'll publish this answer key as well. You can see it's a lot less writing than long division. You can see it's a lot less writing than long division. Okay, awesome. Awesome. Let's get to the factor theorem, shall we? Let's get to the factor theorem. All right, so we can ask you guys now, all right, is x plus 2 a factor of 3x cubed minus 4x squared minus 28x minus 16? Okay, is that going to be a factor? Well, you guys have already figured this out, that if you divide into a polynomial, if you have a remainder of 0, then that x minus a, this linear factor that they give you, is indeed going to be a factor. Okay, this linear expression, I should say, is going to be a factor. So let's see if x plus 2 is a factor. What are we looking for? What are we looking for to see if x plus 2 is a factor? What are we looking for? We're looking to see if there's no remainder, or remainder of 0. Okay. So this is x plus 2. So what am I going to have in my box? I'm going to have negative 2. All right. So go to it. Go to it. Use synthetic division and see if x plus 2 is a factor. Take a minute. Go. Okay, I think you guys are wrapping that up. There's not too much to write. You guys should be pretty good at these. Question in the chat box: could you find a way to use synthetic division to factor something? Well, that's what we're doing. It's a shortcut to long division. Could you use synthetic division to factor? Oh, I see what you're saying. Okay, that's actually example 2. Yeah, no, I see what you're saying now. Sorry. And can you use long division to find factors? Well, if there's, how do you know in long division? It's the same as synthetic division. How do you know in long division if you found a factor? How do you know? No. Shiram's right. If you have a remainder of 0, let me get an example for you here. Yeah. So here. Can you do, no, this isn't going to work. I thought you could factor that too. Yeah, you're using synthetic division to see if x plus 3 is a factor. The answer is 0, so there's no remainder. And now you'd have to factor this. That leaves you with, the quotient can also maybe be factored. We're going to talk about that next. That's trial and error. Well, I guess when you're answering it, yeah, but if the teacher sets up the problem looking for a certain answer, then yeah, you'd be able to expand on the factors. Okay, let me finish this. It might actually answer your question, because I'm actually starting to get confused what you guys are talking about. Yeah. No, I appreciate the discussion. I'm kind of getting confused what you're saying. Because if you have a remainder of 0, you have a factor, and your quotient may be the other factor, or it will be factors of it. Division is the opposite of multiplication. So your quotient, your divisor and your quotient, which let's get to this. Yeah, your divisor and your quotient, because I can explain it once I do this. Your divisor and your quotient are factors. The divisor and quotient are factors of the dividend, or else division doesn't work. I think that's maybe where I'm getting confused. Okay, so no placeholder needed. We got 3, we got a -4, -28, and -16. So we drop this guy down. That's why you need a 1 in front of the x. All right, so we're going to have 3, -10. Sorry, let me just go through the motions here. -6, 10, 20, -8. Remember, you're always adding. And then -8 times 6, -2 is voila. All right, so here's our 0 remainder. Here's our 0 remainder. So is x plus 2 a factor? Yes. We are done with the problem. We're done with the problem. I want to talk about example 2 because I think it's going to answer Arvin McKinley's question, or like add to the discussion here. I want you guys to do synthetic division. So do step 1 and then write out the quadratic expression for step 2. So divide out and give me the quadratic expression. Go. All right, cool deal. All right, so let's get to this. All right, they're saying x plus 3 is a factor. They're saying x plus 3 is a factor. So what's going to happen when we do synthetic division? Yeah, I'm looking for what Sriram is saying. Yeah, there's going to be a remainder of 0, and we're going to result in a quadratic. Yeah, no, so you're both correct. The remainder is going to be 0. So they're saying it's a factor already. You can find out if it's a factor with a remainder of 0. Here we're supposed to get a remainder of 0, so that's a good way to check that you did the synthetic division correctly, because if you didn't, you're not going to get a remainder of 0. All right, so x plus 3, set that equal to 0, you're going to get negative 3. Don't forget to do that part, or at least think of that part. All right, we got 2 in front of the x cubed, a 9 in front of the x squared, a 10 in front of the x, a positive 3 in front of, as the constant. All right, drop down the 2. All right, 2 times negative 3, negative 6. Add these together, 3, negative 3. We got negative 9. We got 1. 1 times negative 3. Okay, so this worked out. All right, so we got our remainder of 0. So what's the quadratic expression that's left? Okay, so x plus 3 is a factor, and then the quadratic expression 2x squared plus 3x plus 1 is the other factor of 2x cubed plus 9x squared plus 10x plus 3. Now, let's list all 3 factors. First of all, you could have, just saying given that x plus 3 is a factor, you could have jumped right down to here and put x plus 3 as a factor. You could have put x plus 3 as a factor right there. Now, you guys need to factor this quadratic expression. Let's see who's the fastest factor in the land. What are the other 2 factors of this cubic? There should be 3 factors. X plus 3 is 1. Factor out 2x squared plus 3x plus 1. What do you got? Some fast factors in here. There's going to be 2, Sid. Yeah, be careful. There's going to be definitely a 2. Yeah. We're going to have 2x plus 1. If you just factor this, forget everything else. If you just factored 2x squared plus 3x plus 1, you're going to have 2x plus 1 as one factor and x plus 1 as the other factor. It's all multiplication. Yeah, you could do 2x plus 1, x plus 1 times x plus 3. You can put x plus 3. Yeah. Okay. Well, now I'm going to ask for the roots, okay? Now, what are the zeros, the roots, the solutions, the x-intercepts of this cubic here? This, I guess to go with your parlance, this random polynomial that we have here. Yeah, we're going to have x equals negative 3 for this one. We're going to have x equals negative 1/2 for this guy, and x equals negative 1. So it's going to hit the x-axis, all between quadrants 2 and 3, on the left side of the y-axis. Cool deal. Okay, why don't you guys do, these are going to be how some of the questions are worded. Why don't you guys do 3, 4, and 5? Do examples 3, 4, and 5.